Hello everyone, welcome to day 4 of March Leetcode challenge, and today's question is find intersection of two linked lists. In this question you are given two intersecting linked lists and you need to identify the point of intersection of these two linked lists. Let's take one example. In this case, we are given two heads, head 1 and A1 and B1, and the point of intersection is C1. We need to return from an answer the intersecting node, that is C1 in this case. So let's quickly look at the algorithm that I have created for this. So let me just start the slideshow. And let's talk about the easiest or the most intuitive way first, and then we will talk about the one which is slightly trickier. Even just before that, if we are sure that two linked lists are of equal length, can we identify the intersection point easily? The answer is yes. So let's assume this is the first list 1, H1, and this is the head of the second list H2. It's very simple to find out the intersecting point. Keep on moving ahead in the linked list. Whenever at a point the iterator of the first list becomes equal to the iterator of the second list, that would be the point of intersection. And very few straightforward lines of code can help you write the algorithm. Now, what is the complexity in the given question? The complexity is only because of the difference in length. So if we can cover the difference of length, then it would be an easier problem. As I discussed, it's very easy to get the point of intersection of two linked lists of equal length. So the problem reduces to covering the distance in the linked list that is of larger length and arriving at the starting point which will from which both the linked lists have equal lengths. How can we do that? So the process is very simple. Let me just change the color of the pen. First of all, let's calculate the length of linked list 1. So the length of linked list 1 is 1, 2, 3, 4, 5. Let's calculate the length of linked list 2. 1, 2, 3, 4, 5, 6, 7. This is 7. And what is the difference between these two? The difference is 2. So we will move the longer linked list by 2 nodes. So this one moves ahead by 2 nodes, 1, 2, and this we get here. Now the length of both the linked list is same. We can do the processing. Take one iterator for this list, one iterator for this list, and keep on moving ahead till the time you don't encounter the same node. So first approach is done. What would be the time complexity of this approach? You are calculating the length uh, of L1 first and then of L2, and then you are finding the difference and moving the longer one ahead by the difference of the two. After that you are moving till the time you don't find the intersecting node. The complexity would be twice of order of L1 plus L2 for this case, because you are first of all finding the length of the two linked lists and then you are moving in the linked list so as to find the point of intersection of the two lists. So let's quickly walk through the other approach where you don't need to identify the lengths first. So let's understand the approach by an example. So this T1, which will be the iterator for the first list, and this is T2, which will be the iterator for the second list. And I'll keep on moving both the nodes till the time one of them doesn't become empty. When will this become empty? When it will reach the terminal position. So let's start the iteration. T1 is not null, T2 is not null. Move both of them ahead. So T1 goes here and T2 goes here. Both of them are not null. Move them ahead. T1 here, T2 here. and then we move ahead again since both of them are not null. T1 here, T2 here, T1 again here, and T2 here. And now we can foresee that if we move T1 ahead, then it will become null. So what we need to do, we need to reset T1 to the starting of the linked list, which is on the other end. We started from H1 here, so and T1 turns out to be a null first, so we will update T1 to H2. So instead of moving this to null, we will update this to H2 and then we move T2 ahead. So this gets updated to not null, however H2. So T1 gets updated to H2 and T2 moves ahead. So we get T2 here and T1 now points to the start of your H2 linked list. What we need to do? We simply need to move ahead till the time T1 is not null, T2 is not null. So we move by one step ahead, move T1 again by one step, T1 gets here, and then again T1 gets here, T2 gets here, and T2 becomes null, and T1 points to this position, and you break the process. Now T1.next will point to your point of intersection, will be your point of intersection. So T1.next is point of intersection. This is what we need to return. So if you want to understand the mathematics behind it, what we are actually doing, we are moving L1 uh, up to a length of L1, and similarly we are moving the second node up to the length of L1. So this also moves up till L1, and how many nodes will be left in the longer list? That would be equal to L2 minus L1, and at this position we reset the other pointer so as to point to the longer list and move ahead till the time this distance doesn't become equal to L2 minus L1, which would be the case till the time this pointer, the other pointer doesn't become null. So we calculated the difference in a slightly trickier manner, and then we manipulated the first pointer to reach the point of intersection. Hope this approach is clear to you as well, and let's quickly code both these approaches. Write the helper method first, where you are calculating the length of the linked list, integer length, and we have list node head integer len equals to 0, while head doesn't turn out to be null. Head equals to head dot next, and len plus plus return len. Pretty simple way of writing the length method. And let's calculate length of the first linked list, that would be equal to length of passing head 1, and let's calculate it for the second linked list. We get len b, and if len a is greater than len b, that means we need to move the first pointer ahead by the difference of the two lengths. So let's calculate the diff equals to len a minus len b, and while diff is greater than 0, head a equals to head a dot next, diff minus minus. Sounds good. Similarly, if it is true for the other way as well, for the case where len b is greater than len a, then we calculate the difference again, and this time we move the second list ahead instead of the first one. Sounds good? Now we are sure that head A and head B are at those positions where the length of two linked lists are equal. What we are going to do, while head A is not equal to null and head B is not equal to null, if head A turns out to be equal to head B, then we will return head A. Otherwise, we'll move the head pointer to the next node. Similarly, for the head B node, we are incrementing the second node as well. Return null. I think this should work. Sounds good. Accepted. So what is the time complexity of this approach? The TC is equal to order of L1 plus L2. And let's try the second approach as well. I'm commenting this code. And let's write the shorter, smarter way without calculating the length. So defining list node A equals to head A, and then again defining list node B equals to head B, and while A is not equal to B, what we are going to do, if A turns out to be equal to null, then we'll update A to the starting of the other list from which we started. In this case it would be head B. Otherwise we'll move A to A dot next. Similar kind of a thing we'll do for the second list. If B turns out to be equal to null, B gets updated to the starting of the first list, and otherwise B gets updated to the next pointer. Once we are done, we'll return A, since both of them will point to the same node. And let me just try this up. It looks fine. Accepted. This is slightly more compact than the previous approach that we discussed, although the complexities would be the same. The order of L1 plus L2. Thanks for watching the video. Hope you enjoyed it. And please don't forget to subscribe to the channel.